All right, we are going to look at a geometric sequence, and a geometric sequence is different than an arithmetic sequence. So here's an example of one. If we have 2, 6, 18, and so on. So the ... tells us that this is infinite, and we notice that there's something different than with an arithmetic sequence from the last time. I notice how I get from 2 to 6, and then I could say I add 4, I could say that I multiply by 3, but then how I get from 6 to 18 helps prove which one I'm truly doing in this sequence of numbers. So it appears that I am multiplying all of these by 3, which is different than what I did last time. So times by 3, times by 3. So now that we've already talked a little bit about writing this in the explicit form and writing this in the recursive form, we're going to try to figure out how this would look for a geometric sequence. So, first of all, we know that our first term would be a sub 1, our second term would be a sub 2, our third term would be a sub 3. So if we're looking at our recursive form, that's usually easiest to find. The recursive formula, we always start with our first term, which would be 2 in this case, and then all the terms after that. So what do I do with the term before to get the next term? Well, in this case, notice how I'm multiplying it by 3. So I have 3 times a sub n minus 1, right? That would be the term right before that I have. Now, I could use recursive formula to figure out the upcoming terms in my sequence. But I might also want to figure out, well, what is the explicit formula so I could figure out the 400th term or something like that. So let's look at these. Let's look at this and try to figure out our explicit formula. So if we start and we have a sub 1, then we have a sub 1 times our ratio. So we're going to call it our ratio of r. So a ratio, it could be 3 over 1, it could be 1 over 3, different kinds of ratios that might appear. So I'm going to call it r. So that would be how we get to the next one, right? So a sub 1 was 2, a sub 2 was our first term times our ratio. So that's how we got 6. Our third term, so we could make this even more of a table. So a sub 1 is this, a sub 2, a sub 3, and showing just what they're equal to. So a sub 3 would be our first term times our ratio, which is the term right before, and then times our ratio again. So if we continue this, we could also say that that's a sub 1 times r, and if we have r times r, that would be r squared, right? So in general, we can see a pattern start to form. So let's do a sub 4. We would have a sub 1 times our ratio times our ratio times our ratio, which is equal to a sub 1 times r to the third. So we have a table here. We'll just kind of make it look nicer-ish. And we see that there's this pattern that evolves. So notice how we can write our explicit function. So in general, our explicit comes from our recursive. So I'm going to write explicit over here. I'll write our recursive over here. So recursive, we know a sub 1 first equals a sub 1. That's what we have to state initially. And then a sub n, in this case, equals r times a sub n minus 1. So whatever that ratio is, we multiply it. So our explicit, we can kind of gather from this last part that we wrote here. So looking at this last example, how can we write our explicit formula? Well, in general, we have a sub n. So notice how our 3 and our 4, they kept changing, right? Equals, but every time we had our a sub 1 in there, So we have a sub 1, and then we're multiplying this by our ratio. But our ratio, one way we can get it, notice we had our exponent of 1 here, 2 here, 3 for the last one. So we're taking this value, this 4 that we had, and we're taking away 1 each time, right? We have 3, we take away 1, we get 2. 2, take away 1, we get 1. So we can say n minus 1 up there. So in general, that's what they would look like. So what would it look like for our first example? So our explicit here, we would have a sub n equals a sub 1, which is 2, times our ratio, which is 3, to the n minus 1. So notice here, let's just do an example. We could just do it out loud. If we're plugging in 3 minus 1 would be 2. So 3 squared would be 9. 9 times 2 would be 18, which is what we got right here. So our explicit and our recursive for that first sequence would be as follows. So let's try another one. Here's our explicit and our recursive for geometric. And we have a sub 1 is our initial value still. And our r is our common ratio. So we have these two ways of writing our geometric sequences. All right, so let's try another one. You try to write the explicit and recursive form of this sequence, okay? So you try, after we write out the first few terms, so we're going to start at negative 1 over 32, 1/8, negative 1/2, 2, and it keeps going. So pause the video right now, try to write those equations on your own, and then come back to it. All right, so you've tried this on your own already. Now, let's look at what is our first term. So we know a sub 1, so recursive, explicit. For both of them, it's important to know what a sub 1 is. So I'm going to list out what my first key terms are. So a sub 1 equals negative 1 over 32, right? That was important for both of them. Then let's think about our ratio. So what are we doing to go from the first term to the second, or the second to the third, or third to the fourth? Sometimes it might be easier to think about numbers that are easy, right? We know that we're multiplying it by something because it's a geometric, or it appears to be geometric, right? So negative 1/2 times what gives us 2? Well, we would have to have 4 over 2 to get 2. And then we'd have to have a negative out front to get that positive. So let's see if negative 4 works for everything. So if I have negative 1 over 32 times negative 4, well, I get 4 over 32, and that reduces to 1/8. The negative times the negative cancels out. And I could check the same with the middle term there. So what I'm doing every time is multiplying times negative 4. Times negative 4 to go from one to the next. So then, if I have negative 4 as my common ratio, I can write my different forms. So recursive a sub 1 equals negative 1 over 32, and a sub n equals our ratio, which is negative 4, times a sub n minus 1. So the term before that, we multiply by negative 4. Our explicit, we would say a sub n equals negative 1 over 32 times negative 4 to the n minus 1. Now we would keep both of these negatives here because this negative with the 4 has to have the exponent with it first, and then we multiply it by the negative 1 over 32. So you wouldn't simplify this, you would leave it as it is. Okay? So using these, we could also figure out what our 800th term is if we wanted to, right? So think about which one you would use to find a term later on. So would you use recursive to find your 100th term? Probably not, because to find the 100th term, we would have to do all of the terms before that. Whereas if we plugged in that into explicit, we could just plug n equals 100 and then figure out a sub n. So on the next practice, you'll be applying these two formulas in more ways than what we're showing right here. But use these general formulas to help you practice with geometric sequences. Remember that you're trying to figure out what multiplies. It could be a whole number, it could be a fraction, but that's something that you're looking at. So if there's just one more example, just looking for what is our a sub 1 and what is our ratio. If we have the sequence 24, 12, 6, and it keeps going, then our a sub 1 is what? It's 24. And our ratio here, well, what do we do to get from 24 to 12, or from 12 to 6? We're going to multiply by a half. Right? So our ratio is 1/2 here. So we would use that to solve and figure out our different equations. So you'll use that more so in your practice, and then I will see you later.